Now that we have discussed about congruency rules and the applications of congruency rules in solving or deriving many mathematical or geometrical properties in mathematics, now comes the concept of the unequal angles and unequal sides connected with the geometry of triangles. Before we get into the unequal sides and unequal lengths of the triangles, let's get into understanding the basic concept of the length of the side connecting the size of the angle. Length of side versus size of size of angle. So let's see how we can connect the length of the side of a triangle with the size of the angle as that made. Before we get into understanding this, let's take a smaller line. Imagine I have a tree out here, or this is a palm tree which I have out here. So imagine this as the palm tree which I have, and I'm standing out here to watch the palm tree. Now I have an angle, say this angle is theta 1. Imagine I have a second case where I have a small bush and I stand here to the same distance and then watch the bush out here. So this angle is theta 2. Then what do we observe from these two real life situations? Here is the palm tree, and say I have one more case where I have an Eiffel Tower out here. And I'm at the same distance watching the top of the Eiffel Tower. I have three cases: theta 1 where I observe the top of the palm tree, theta 2 where I'm at the same distance and observe the top of the bush in the lawn, bush in the park, and I'm at the same distance where I observe the top of the tower from the distance which is theta 3. How do you connect the relation between angles theta 1, theta 2 and theta 3 is the biggest question out here. How do we connect? As we can understand through real life situation that bush is smallest of all the three sizes as compared here. Bush is to a height of this, and a palm tree would be around 30 to 40 feet, and an Eiffel Tower which is very tall, more taller than the apartments and the buildings. So here we know that this is of a greater height, this is of the next greater height, and this is the least of all the heights. Therefore, the one which is the least of all the heights makes the lesser angle. The one which is greatest of all the heights makes a greater angle. Therefore, here I understand that theta 2 is the smallest angle, because since size of or height of bush smaller, and theta 3 is the largest angle. because height of tower, since tower is the tallest of all the three different situations which are taken out of the bush, the palm tree, and thus the tower is the tallest. That's how we understand the connection between the bush, the palm tree, and the Eiffel Tower. Therefore, the least of the all angles θ1 and θ2 and θ3 is identified to be θ2, which is the smallest angle, simply because the height of the bush is smaller, and θ3, which is the largest angle, because tower is the tallest and the bush is the smallest. Is how we understand the relation. Therefore, connecting the inequality with the angles here, I clearly see that θ2 is smaller than the angle θ1. Next comes smaller than θ3. Is how I connect the real life situation with the angles. Lesser the angle, lesser the side, or lesser the side, lesser the angle opposite to it. As how we have the triangle connected with the angles of different heights.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.